Okay, so for part 3 of video 1.2, resolution of forces, we are going to look at another two more example which involve combination of 1.1 in resultant force and 1.2 resolution of force. So the questions will be a bit trickier, but it's still not that difficult. Okay, so example 3, a man is pulling a bag with a force of 40 Newton at an angle 30 degree. The weight of the bag is 20 Newton and frictional force acting against the bag is 30 Newton. Draw a free body diagram to show all the forces acting on the bag. Okay, so to draw the free body diagram, let me zoom the diagram first. Okay, so the boy is pulling, so we label as the pulling force as F, and then we have weight of the bag, label it as W, and frictional force acting against the motion of the bag as Fr. Next, draw a horizontal component of the force. So the force here is force F. Okay, so let's draw force F here, and as usual we have to resolve into two, which is the vertical component and horizontal component Fx, and the angle given is 30 degree with the floor. So the angle is here between F and Fx. Since these all are vectors, so we can just move the vector around as long as the length is not changed. So I am going to move Fy to the left side. So erase Fy here and draw Fy on the left side. And there you go, your right angle triangle. So F given is 40 Newton. So to calculate the horizontal component, by now you should already know that horizontal component is adjacent to the angle 30 degree. So we can use cos, because the formula for cos is the component adjacent over hypotenuse. So adjacent is Fx, hypotenuse is 40 Newton, and you calculate it using your calculator. You will get Fx equals to 40 cos 30, which is 34.64 Newton. Next, find the vertical component of the force. So for this one, you are going to use sin 30, because sin 30 is opposite. The component opposite is Fy over hypotenuse 40. So Fy is 40 sin 30. Use your calculator and you will get 20 Newton. Next, calculate the resultant force acting on the bag. Okay, so this question here is actually a question from subtopic 1.1, resultant force. But here, since you have two direction, okay, let's look at the diagram. So you have direction horizontally, which is to the left, and frictional force acting against, that is horizontal direction. You also, okay, at the same time, you also have direction in the vertical. Here, you have Fy and also W. So you have to calculate the resultant force for both direction. Okay, so let's draw the diagram first. So you have Fx, which is 34.64 to the left, and then you have frictional force acting 30 Newton. You have vertical component, which is 20 Newton, and also weight component, which is also 20 Newton. Okay, so the original force is, let me draw. Okay, so this is your original force, which we have already resolved into 2. Okay, so let's do for horizontal first. So horizontal resultant force is equals to Fx plus F. So Fx that you have found just now is 34.64, but bear in mind that the direction is to the left, so you have to include negative 34.64 Newton plus 30 Newton frictional force, and you will get 4.64 Newton to the left. Okay, so you may get a negative number, but that's okay. You can write it as 4.64 Newton to the left. Next, find the vertical resultant force, which is Fy plus weight. Okay, so Fy that you have found earlier is 20 Newton, and weight is negative 20 since the direction is downward, and you will get 0 Newton. So the answer is the resultant force is actually 4.6 Newton to the left. Next, if the mass of the bag is 2 kg, calculate the acceleration of the bag. So this one you are going to use Newton's second law, F net equals to ma. So the resultant force that you have found from the previous question is equals to the net force. So you just substitute 4.64 here, and then you substitute the mass of the bag, 2 kg, times the acceleration, and you will get the acceleration is 2.32 meter per second. Next. Okay, so here, the problem given to you is an object on an inclined plane. A cat weighing 24 Newton is going down on a slide at an angle 60 degree with the ground. Normal reaction acting on the cat is 12 Newton. Okay, so since there is no information on the surface of the slide, we can assume that friction is 0. We can assume that it is a smooth slide. So frictional force is 0 Newton. Draw a free body diagram of all forces acting on the cat. So we have weight acting downward and normal reaction acting upward, and must be 90 degree to the plane. If we have frictional force, we need to label frictional force acting to the left, but since this is a frictionless slide, then we consider there is no friction, then we don't have to put friction in the diagram. Next, calculate the component of weight parallel to the slide. Okay, so I have explained in the first video, part 1, that the component here, since it is acting on an inclined slide or inclined plane, so we still have to resolve into 2, but we don't call horizontal or vertical component yet. We don't call vertical or horizontal component. We call it as component parallel to the slide or component perpendicular to the slide. Okay, so let me highlight with blue color. So that is your slide. Okay, so if you want to resolve W, you can resolve it into 2, which is component that you can call wy. So this component is a component perpendicular to the slide. You see, it is 90 degrees to the slide, and also a component that is parallel to the slide. Okay, you see, it must be a straight line. Okay, that is just my rough drawing. So it should be parallel to the slide. Okay, transfer here. wy and wx. Okay, so the angle given is 60 degrees from the ground. Okay, so as you know, if the angle from the ground is 60 degrees, then the angle between w and wy is also 60 degrees. Okay, this is your angle, 60 degrees. Okay, so you can use triangle force method, which you can move the vector to form a right angle triangle, which I will do here. I'm going to move the vector wx to form a right angle triangle. Okay, so that is wx. So to calculate the component of the width of the cat parallel, so it is obvious that we should use sin 60 equals to wx over w, and w here is given 24 Newton. So use calculator and you will get wx is 20.78 Newton. Next, to calculate the component which is perpendicular to the slide. So the question now is asking for wy. So now you can use cos 60 wy over 24, and you will get wy equals to 12 Newton. So next question. Find the resultant force. Similar to the previous question, we have to split into two. Resultant force of the component perpendicular and parallel. So I think I'm going to do parallel first, and then we are going to do the perpendicular. So for parallel, it is wx plus friction. Okay, see, wx plus friction. But since there is no friction, this is the component parallel, the one I highlight in pink. Since there is no friction, so friction is 0, then wx is simply 20.78 Newton. Whereas for perpendicular, it is r plus weight. So resultant force is r, and wy is negative 12 Newton. Since the direction is downward, so we get 0 Newton. So the resultant force is 20.78 Newton. And the last question is, if the mass is 2.4 kilogram, find the acceleration of the cat. Simply substitute in the Newton's second law, F net equals to ma. So F net is what you have found earlier, 20.78, mass 2.4 times acceleration, and you will get acceleration is 8.66 meter per second square. Quite a high value, but that is the value when you have a frictionless surface. So that's all for subtopic 1.2. Thank you.